Okay, we are still looking at static equilibrium, and this one will now lead us to our talk. We want to look at the case of torque under this discussion. Please don't forget, for static equilibrium, there are conditions that must be fulfilled. It means that we need to meet to some certain condition under static equilibrium. Meaning the first one is that the net force must be zero. The net force must be zero. That is to say, the sum of the forces in the y will be zero, and also the sum of the forces in the s will also be zero. This one has to do with translational equilibrium. And also another condition is that the sum of the torque will also be zero, and this one has to do with rotational equilibrium. This one has to do with rotational equilibrium. But for this very aspect of discussion, this very aspect of today's discussion, we are going to focus more on the second one, which is the sum of the torque equal zero. Now, let us now see the meaning of torque. What is torque? Torque is also known as moment. Torque, also known as moment or moment of force, is the tendency of a force to cause or change the rotational motion of a body. It is a twist or turning force on an object. Torque is calculated by multiplying force and distance. It is a vector quantity, meaning it has both direction and magnitude. It has both direction and magnitude. Okay? Please don't forget I said that torque is simply calculated by multiplying the force and distance. It means that we can determine the formula for torque. It means that for torque, we simply mean that it's simply the product of force and the distance. The product of force and the distance. You take notes, the product of force and the distance. It means that torque can as well be written as F times distance. That is the formula for torque. Now, what is now the unit for torque? Torque has a unit. Torque has a unit. Meaning we have units for torque, units for measuring torque. You know, for force, we use Newton, while for distance is meter. Therefore, we cannot conclude that Newton meter is used for measuring torque. Newton meter is used for measuring torque. Please take note of that. Very, very important. Take note of it. Very important. Please don't forget I said earlier that the second condition will be considered under this discussion, this second condition. Okay, not that we will not focus on the first one. We are still, there are some areas we are going to apply this first one, but this one will be used in most cases. This one will be used in most cases. Okay, now that one is for this aspect. Okay, we are able to determine the unit. We can also determine the dimension for. We can also determine the dimension for torque. It means that torque also have it has a dimension. Now, from the formula we can determine the dimension. Don't forget that torque is simply F times distance. The F there stands for force, which is equal MA, and also A is also the change of velocity with time. You take note, change of velocity with time. Okay, now I can say here, I can determine the dimension for this one, and therefore velocity is simply displacement over t, and also we have another t again. It means that in this case now I can say t all over t squared. Therefore I can now say the dimension now become L. Dimension become, for this one is L, while for this one we still use t for the dimension become t second. Therefore I can say now for this one I can say that for acceleration I can say that the dimension is LT squared for the one of acceleration. Okay, if I bring this one here to this position here, therefore I will now have for the acceleration, I will now have the dimension, and the dimension there become L T power minus. Is it not power minus 2? Yes. Look at it here, it's going to be power minus 2. We take note for the acceleration, it's going to be lt power minus 2. You know this one is a denominator. You have to take the reciprocal. You have to take the reciprocal. Look at what I'm trying to say is that a is equal for the dimension there. We have t all over t squared. And I told you that L is the dimension for distance, while for T we use T, capital letter T. Okay, become T squared. Now taking the reciprocal, you know what will happen? Become L T power minus 2. Therefore, this one is the dimension for acceleration. Now when we bring it here, I will have this very one here. Therefore, now for force, I cannot say the dimension become, it means that the dimension will now be T power minus 2. Okay, that one becomes the dimension of force. Altogether, become NLT power minus 2. Okay, if I bring it to this very point here, I cannot say, from what I have there, I cannot say that, let me remove this one, I can say for the dimension, I cannot conclude and say for the dimension, I cannot conclude and say that this very one here, for the dimension of torque, I cannot say that T is equal bringing F. Look at it. This one is F, and of course we have our dimension on this dimension. That is L. That is M L T power minus 2. And what is the other one? We have, from the formula, we have distance. Look at it. This one is for the F, while the distance that is times L. And when we do that, we are going to have T equal L times L is going to be N L squared T power minus 2. Therefore, this one becomes the dimension. This one is the dimension for torque. This one is the dimension for torque. Please take note of that. That is the dimension for torque. Okay, I think we are able to determine the formula for torque, the unit for torque, and also the dimension for torque. Please take note of this very aspect. It is very important. Okay, it is very important. Meaning, in our next teaching, we are going to consider other area in torque. We are going to determine the formula, other formula we can also apply in solving torque. Okay, and that one will now lead us to using this very one. This one will lead us to this second condition in our next line of teaching. Okay, all the best. Please don't forget to like my page, Facebook page, JB Jumbo Online Mathematics, and also subscribe to my YouTube channel, Mathematics Science Mega Tutorial. All the best.